Hello dear students, we'll proceed with this variation in molar conductivity with different concentration. Okay, today we will see in case of weak electrolyte and strong electrolyte what are the effects. So the conductance, first effect is what? Conductance. So what is the effect of conductance on varying the concentration? Okay, so first if you think you are diluting a dilution, if you increases the dilution of an ionic solution, then what happens? The concentration goes decrease because you are adding water and the concentration will decrease. Okay, the symbol decreases. Okay, once concentration get decreases, what happened to the conductance? Conductance will increase. This is the case for both weak and strong electrolyte. How it works in both the cases? Okay, see, if you consider weak electrolyte, suppose we have taken weak electrolyte here. So what is weak electrolyte? How do you know that this is weak electrolyte? Or acetic acid, if you will take acetic acid is weak electrolyte, we know that. Why? Because weak electrolyte, there will be no 100% dissociation into the ions. No 100% dissociation. Maybe 40%, 50%. That means the solute will be, reactant part will be there in the solution as well as the product part, the ionized part. Okay, so what happens if you will dilute it? Suppose initially you have taken the volume of solution and there you know that 100 molecules of weak electrolyte dissociated to 50 molecules. Okay, and rest 50 molecules are there only. When you dilute it, you are diluting this side. So what happens? These 50 molecules, the remaining 50 molecules tries to give more ions. Okay, at least it will give 4 or 5 more ions maybe. Not 100% because this is weak electrolyte. But it may give 4, 5, 6 or 10 molecules, more number of molecules or ionized molecules. And more is the number, more will be the conductance. This is the case of weak electrolyte. Understood? If you take strong electrolyte, this is the case of weak electrolyte. This is how on dilution the conductance increases in case of weak electrolyte. If you are taking strong electrolyte, we know that what strong electrolyte, the role of strong electrolyte? Completely dissociated, 100% ionized, completely. Yes or no? That means if you are taking KCl, so completely K plus Cl minus it gives. Completely. Already the ionized part is complete. The number of ions are fixed here. Here it is not fixed. In case of dilution, there may be chances of more and more ions to be produced, and that ions can carry the electrons, and by which the conductance is increased. But here the confusion creates. Yes or no? So this is again 100% ionized, right? 100% ionized. Since on dilution it gives more, increases the conductance. How? Let's see. So here what happens, if the volume is V volume, suppose V volume, the K plus and Cl minus ions, K plus and Cl minus ions, the density of these ions is quite high. They are close. Once you will dilute it, K plus and Cl minus ion, they have one kind of electrostatic force of attraction between these. And on dilution, the water molecules has the tendency to break these force, and by which they are just away, the distance between the ions are just away, and as they will away from each other, there will be no force of attraction. Their mobility, ionic mobility will increase, and hence they will conduct the electricity, they will conduct the electrons. So this is how the conductance increases on increasing dilution or decreasing in concentration, for both the case, strong or weak electrolyte. Now we will see about the conductivity. What happens to the conductivity? Conductance increases. Now we will see about the conductivity. Okay. So basically these things you can get by the experimentally. Okay. Experimentally you will get these sort of things. So again on dilution increases. Okay. Dilution increases. What happen for concentration? Decreases. Yes or no? Is it visible? So on dilution increases, concentration decreases. What happened to the volume? As I said, volume increases, obviously. Okay, volume increases. And what will be the number of ion or density? Density decreases. Density decreases here. And again, if density decreases, that means number of ion per unit volume what? Decreases. Why this I am taking? Because what is conductivity? Conductivity is the conductance in 1 ml of volume of solution. So per unit volume, that is what number of ion per unit volume, or 1 ml. In 1 ml the number of ion will decrease on dilution, obviously, because density will be less, ionic mobility will be more, so ions will get a chance to move out. Suppose here 1 ml you have taken and you are diluting it. So this 1 ml, the ions present in this 1 ml, if you dilute it, they will move towards this, and obviously in fixed 1 ml the number of ion will be less. So that is what the number of ion per unit volume will be low, and number of ion per unit volume will be low, and conductivity will low or decreases. Conductivity is nothing but kappa. Kappa is low. Okay, understood? So what we'll get? Last time we know that the relations between molar conductance equals to kappa into 1000 divided by molarity, whereas equivalent conductance equals to kappa into 1000 divided by normality. And on the relation we know that the relation both are same, the behaving the molar conductance and equivalent conductance, the behavior is quite same. So if you will consider one thing, that in case of molar conductance, suppose dilution, you are increasing dilution, what you are getting, the conductivity decreases. Okay, as you will decrease the conductivity, kappa value decreases, that means molar conductance value will decrease, because this is directly proportional to kappa. Okay, again in case of equivalent conductance also directly proportional to kappa. So if kappa is decreases, then the both conductance value will be decreases. Okay, one more case is there, molarity and normality, right? Experimentally, okay, let me clean. So experimentally, what we got, dilution increases. Here we have two factors, that is del m equals to kappa 1000 divided by m for equivalent conductance, kappa into 1000 divided by n. Okay, that means it also depends upon the molarity and normality, because these are the concentration. If your concentration is there, if concentration varies, obviously it will affect the molar conductance or equivalent conductance. Okay, if there will be no concentration, then there will be no conductance. So obviously it also depends upon the molarity and normality of the solution, concentration of the solution. So on dilution, what happens? The volume increases. Okay, if volume increases, dilution increases, volume increases. Volume increases means the concentration, normality and molarity. What happened to this? Molarity will decrease, normality will decrease. Yes or no? Okay, if concentration terms will decrease, the concentration of the solution get decreases, then what happens to this? Molar conductance and equivalent conductance, what will happen? Increases. This will again increases, because right now we have seen that if dilution increases, the conductance value increases. Why? I just said the mechanism behind. Why? In case of weak electrolyte, what will happen? In case of weak electrolyte, there will be the formation of new ions. That's what those new ions will carry that electrons, and by which the concentration will, or by which the mobility, ionic mobility will be there, and that's what the conductivity will be more. So in case of strong electrolyte also, there will be the ionic mobility, there will be the 100, though there is a 100% dissociation, the ions present in a strong electrolytes are very closed by means of electrostatic force, but due to the dilution there will be the gap between these two oppositely charged ions, and due to that there will be more ionic mobility and there is a chance of conductivity. Okay. So experimentally what we got, that del m or del q, del eq, equivalent lambda m or lambda eq, that is the molar conductivity or equivalent conductivity, depends more on molarity and normality. Rather than depending on this kappa value, it depends more on these molar concentration terms. So we need to consider this, not to this. Okay. So though we have a confusion over here, kappa value, by decreasing the kappa value, this is decreases, but by increasing the volume or by decreasing this molarity and normality, because these are the inversely proportional to the concentration terms. So as it is decreasing, molar conductivity and equivalent conductivity will increase. So we need to consider these, because experimentally we got to know that these two values depends more on the molarity and the normality of the solution. Okay. So for this, one case has been for the strong electrolyte. There is one scientist who did the experiment and he concluded few sort of formulas and few sort of things to so let's see what is that. Case 1, take case 1. Variation of molar conductance with the concentration of strong electrolyte. Strong electrolyte, he has taken the strong electrolyte and he formulated something. Only strong electrolyte he has taken. Okay. So from this graph you will get to know he has taken molar conductance and root C. This side in x-axis, this is root C. Why this is root C? From this graph you will get to know. When he has taken, he got a straight line, root C, because while we are believing that we need a straight line, then only you can easily calculate, because of that y equals to mx plus c. We need to formulate this figure so that we can easily calculate what exactly the slope, what is the concentration. So for that they have calculated the concentration terms and root C. In root C it comes out the straight line. Okay. So if you draw this thing, he has taken strong electrolyte KCl. Okay, and he got this. This is what? 0, and this is y-axis, and this is molar conductance, and this is concentration. So this is the higher is the concentration. As he came from the higher concentration towards the low concentration, that means dilutions, on dilution, the conductance value, what happens to the conductance value? It increases. A slight slope that determines increases, and this is what lambda m infinite. Okay, that means here at this point molar conductance is there high at 0 concentration. At 0 concentration, here you can see this axis, once it achieves this, so this is 0 concentration. Concentration level 0 means you are diluting. From here you have started, you are diluting it. As the time goes off, you are diluting more and more. a time will come that it will achieve to this point where the concentration term will be 0 at higher the maximum value. So we have taken lambda f infinite, means there will be no more dilution or no more, nothing will happen to the concentration. So that at that moment concentration will be 0 and the conductance will be at infinite. Okay. So from here we know that concentration is inversely proportional to volume. Yes or no? As we are diluting it, as the volume rises, the concentration decreases. Okay. So for this statement, for this y equals to mx plus c, y is nothing but del m equals to mx plus c, what is x axis, that is root c, plus c, that is nothing but the del m infinite, and what is the slope? Obviously slope negative of, suppose you have taken negative b, root c plus del m infinite, or is it visible? Or del m equals to del m infinite minus b root c. This is the formula that he has formulated, and this formula is known as Debye-Huckel-Onsager equation. For strong electrolyte. What is the B? B is the constant value. B is a constant. B is a constant that depends on the solvent, which depends on solvent. Okay. And for weak electrolyte, he has taken again these things for the weak electrolyte, and what he got for weak electrolyte, he got a curve. This is del m, this is root c. So it's coming curve, so there will be no value of using this Onsager equation, because it must need a straight line. Okay, the curve will be curve is like this. Okay, is it visible? Okay, so next, to resolve these issues, one more law is there, that is what? Kohlaraushs law. Okay, let me clean, we'll go to that part. Hello. So let's check Kohlaraushs law. Very easy law, very interesting. This is applicable for both strong and weak electrolyte. Okay, for both strong and weak electrolyte, very important also, board and competitive point of view. So what is the law? Let me explain first. At infinite dilution, molar conductance of infinite dilution of any electrolyte, okay, any electrolyte is equals to the sum of lambda m infinite of cation plus lambda m infinite at anion. This is the law. That means, suppose NaCl is given for NaCl, okay, equals to lambda m infinite of Na plus ion plus lambda m infinite of HCl minus ion. These values will be given. Suppose new number of if new plus ions present and new minus ions present. Suppose. So what will the formula? Del M infinite of any electrolyte equals to nu plus of cation at infinite dilution plus nu minus of anion at infinite dilution. Okay, is it clear? No? Now it will clear. Suppose infinite dilution of carbonic acid H2CO3 is given. So here you know that 2. How many H plus ions are there? How many? 2. Right? So 2 lambda m infinite H plus how many SO3? 1. So lambda m infinite SO3 plus. Okay. So now you can write the definition also. The molar conductance of a strong or weak electrolyte at its infinite dilution. From this we can figure out the law. Again I am telling, the molar conductance of what? Strong or weak electrolyte at infinite dilution is the sum of what? Cation and anion at infinite dilution of that electrolyte. At its infinite dilution. Again I am telling, the molar conductance of any electrolyte at its infinite dilution is equals to the sum of the molar conductance of cation and anion at its infinite dilution of that electrolyte. Okay, but here you have added this cation and anion, that part also you have to mention. The molar conductance of a strong or weak electrolyte at its infinite dilution is the sum of what? Is the sum of molar conductance of cation and anion at its infinite dilution, in which the number of ionizable cation and anion to be multiplied. Okay, understood? So now let's do one problem, how it deals with. Let me clean. Okay, so problem is that the molar conductance at infinite dilution of NaCl is given that 125 Simon centimeter square mole inverse. Molar conductance at infinite dilution of HCl is given 427 sim square mole inverse. Okay, and acetate, sodium acetate, molar conductance at infinite dilution of what? CH3COONA is given 90 cm square mole inverse. So find the molar conductance at infinite dilution of acetic acid. How will you do this? Okay. So this is what given. NaCl. Infinite. NaCl means what? Infinite of, according to Kohlaraushs law, Na plus lambda m at infinite dilution of Cl minus, which is equals to 125. Yes or no? Yes. For HCl, lambda m at infinite dilution H plus lambda m at infinite dilution Cl minus is given 420. Okay. So next, acetic acid, lambda m infinite Cs, this is Na plus lambda n infinite CS3 COO minus, which is given 90. So this has been asked, that is what? Lambda m infinite H plus lambda m infinite CS3 COO minus. This value is needed. How will you solve? Simply look, H plus you are required, this value you need to know, and again this value you need to know. Yes or no? Suppose equation 1, equation 2, equation 3. So from these two, by adding these two, what you will get? This value and this value. So add 3 plus 2. Then if you will add this along with these two, you will get Na plus and Cl minus also. Okay. So minus with this equation 1. So here Na plus and Cl minus will be get cancelled, and you will get the value of only this. That means 90 plus 420, 90 plus 420 minus 125. So 510 minus 125. Your answer is how much? 385 7 cm square. This is how you need to solve the problem. Very easy. And remember, so I'll give some more questions on it. Next we'll go to the cell, electrolytic cell. Thank you.